Okay, the next rule on the list is something called the chain rule. That's when you try to take the derivative of a function inside of a function. Now, I've actually already done this 3 or 4 different times, but here's a couple different instances of what we have it. We have taken the derivative of e to the 3x. We wrote that as e to the x times e to the x times e to the x, use the product rule, and we wound up getting 3 times e to the 3x. Now, this is a chain rule problem because the inside function is 3x. I usually call the inside function blob. That's actually very helpful for me later on. The outside function in this case is e to the x, and so the composite would be e to the 3x. We have taken the derivative of cosine to the fifth. I think actually you took the derivative of cosine to the fifth. You write cosine times cosine times cosine times cosine times cosine. You use our general product rule, and you're going to wind up getting 5 times cosine to the fourth times minus sine x. This is a composite function, however. There is an inside function. It's cosine. There's an outside function. That's what we're doing to cosine. We raise it to the fifth. Another one we've done, although it's been a bit hidden, we took the derivative of the square root of 5x. The way we did that is we rewrote that as the square root of 5 times the square root of x and just used what we knew. The answer is 5 over 2 square root of 5x, but it does have an inside function, 5x. It does have an outside function, square root of x. And so when I actually look at the first function here, I usually try to read this, for example, as e to the blob, blob to the fifth, square root of blob. Now, all of those seem to be just a matter of rewriting. I did want to do one where we actually had to think a bit harder and use some pictures. It's not a bad thing to do. So what I'm going to do is go to the whiteboard and try to take the derivative if I can. Here we go. Derivative, if I can, of sine of 2t. And I think my black marker is going to start protesting, so we'll do it this way. Now, I know how to take the derivative of sine of t, and what I want to do is compare the derivative of sine of t to the graph of sine of 2t. So here we go. The graph of plain old sine just runs like this, like this, where this is t. The graph of sine 2t is similar. It just goes up and down twice as fast. So it goes like this, and like this, and like this. Now this is the graph of sine of 2t. Now, if we want the derivative of the sine of 2t, what we're doing is we're picking a t value. So there's t right there, and we're looking at the graph, and we want the slope of that tangent line. The problem is I don't know the slope of that tangent line. So what I want to do is compare it to a slope on this graph. Now, what do we have to do to this graph down here to get this graph up here? We have to stretch it by a factor of 2. So that's going to take this point that used to be at t, and it's now going to be at 2t. And we can find the slope of that line. The slope of that line, because we know the derivative of sine is just cosine. So the derivative of sine at 2t, now that's not what this asks for. This says if you're looking at the graph of t, of sine of t, and you want the slope of the tangent line at 2t, that's just going to be cosine of 2t. That's the slope of this line. It's not the slope I want. What I want is the slope of this line. But I want to say something I just said a minute ago. What's the relationship between this graph, the one I want, and this one, the graph I could figure out? This graph is going up or down twice as fast. So the slope I want here is twice as big as the slope here. So this is going to be 2 cosine 2t. And so I'm going to write this up here. I'm going to write this as cosine 2t times 2. And I'm going to repeat this for all the others. But the way I'd like to read this is the derivative of the sine of blob is the cosine of blob. And then there's this extra. What is that extra? I believe that extra is just the derivative of the blob. So when I have a function inside of a function, for example here, if I have the derivative of sine of blob, it's going to be cosine of blob times the derivative of the blob. Now let's go back to those other 3 examples we had, if I can get it to do it. And I just want to look at each of those examples. Let's see, first example here, that's e to the blob. Well, the derivative of e to the blob should be e to the blob times the derivative of the blob. And if you look at our answer over here, that's exactly what we have. When I take the derivative of blob to the fifth, I should get 5 blob to the fourth times the derivative of the blob, which is exactly what happens here. When I take the derivative of the square root of blob, I should get 1 over 2 square root blob, which is what I got here, times the derivative of the blob, which is 5. So that does give us what the chain rule actually says, that the derivative of f of blob is just f prime of blob times the derivative of blob. In the next little video, we'll try to run through, I would say, 5 or 6 examples.